Hello everyone. Today I will go through Rust embedded on bigger MCUs. Specifically, I'm interested to see how I can make a Wi-Fi project. And for this I will use one of the chips that has Wi-Fi built in, and this is the ESP32 chip. In this case I will use the C3 variant. ESP32 comes in different variants. Some of them are just called ESP32-S2 and I think S3 and so on, and those are based on an Extensa architecture. And because Extensa is not supported in mainline CLang, you will need a special fork of CLang that will support that architecture. So for this, instead I will use the C variant, which is a RISC-V MCU, and which mainstream CLang can compile by default. In order to get started, I will use a template that is provided by the Rust RS team. So it's the Rust RS ESP-IDF template. There are other examples which I will link below. One of them is from Ivan Markov that has a lot of demos built into a single app. It connects to Wi-Fi, it does pings, it does HTTP servers. I started with this. However, the example is complex enough that just going through a video and updating would take too long. So I will take the hopefully easier route of starting from scratch from a Hello World app and connecting a display because I have an I2C interface, and then connecting to Wi-Fi and see how that goes. Let's get started. So I went already with all the instructions over here. You have to install Rust nightly, you have to install some cargo generate, and the instruction that I will be starting with is the generation of the project, which will be a brand new project. Let's say C3 Wi-Fi as a name. This will create a directory with the same name. ESP has various ESP IDF releases. This is the SDK and the compiler, like all the headers and all the definitions needed to compile ESP projects. Generally, this is for C, C++. However, because we're in Rust, the build system will be configured so that it compiles Rust first and then goes through these systems. I will choose the latest stable one, which is 4.4. I think it was reasonably recently released. And because I have a C3, I can use nightly. I don't need to use the fork of ESP. And the big difference from previous Cortex-M videos that I made, this has full STD support. This is a big MCU. So I will compile it for C3, and I will change into C3 Wi-Fi, and I will start a build. The build will be very slow because especially at the end it will compile the whole ESP IDF. So I'll speed it up, but while it's going I will also describe a little bit more the system. I was looking at this data sheet, and the important part to see, this is a big MCU. Like I have 400 kilobytes of RAM. I think it says ROM flash 384, but my board may have actually 4 megabytes of flash as far as I'm aware. And then because I will connect a display, I know I have at least one I2C, well, exactly one in this case, and there are various other interfaces that I can make use of. Alright, so it is compiling. I will stop the video and start it again when it actually finishes compiling. I think it takes a couple of minutes because it will end up compiling about 2 gigs of data. Welcome back. You can see that the compilation took 2.1 minutes and I have quite a beefy system. And if I check the size, it compiled 2.4 gigabytes, and if I look at the target, 1.1 gigabytes is in the target, and then there is also the tool set for compilation. So this is a big system. Let's start editing things. I will resize the window a little bit. At this point, I have a project that compiles, and I expect it to print hello world, and cargo build is instant because it's already built. The other part is how do I flash, and I have flash instructions here using ESP flash. So I compiled this before. I will copy and paste, but generally the binary is the same as the project name, and I will show a few arguments. So first of all, it's monitor. After you compile, it will flash the device, but then I would like to stay connected to the device and see any debug outputs. In particular, this println hello world I would like to see on the console, and ESP itself will show some debug logs as well, and they are lightly colored. The other one is speed. For me, this high speed works quite well. I think the default is 115/200. So a bit over 100,000. This is at least 8 times faster. So basically flashing is fast. The device, the image itself is quite big. So if I do cargo size A, it will tell me that just the flash is 95K. So I have to write 95K to the device, which is really on the slow side. So in this case, let's get to flashing. This takes a bit, not as long as after I enable Wi-Fi. So you can see at boot time, I have all sorts of image information. I have a clock frequency, which if I count the zeros, it's 160 megahertz, so it's quite fast. And then I have information about RAM. It looks like 400 kilobytes as I expected, but it's a little bit split. And then I have the final hello world, which is exactly what I expect. So now let's make a plan what to do. So first of all, what I would like is to connect the device. I used to have an SSD 1306 device, and I would like to use it, and I would display some text. So in order for me to use SSD 1306, I will need to find out how I2C can be enabled, and then I need to create a SSD 1306 display, and I will display the text. Let's get started. The first thing to do is I will need a hardware abstraction layer for this. So if I do cargo search ESP IDF, I will need a hardware abstraction layer. I can see that the hardware abstraction layer exists. So it says hardware abstraction layer for ESP family. And then I also need IoT development framework because I will need Wi-Fi. So I will take both of these and I will add them to Cargo Tomo. IDF is already there, HAL and SVC. Let's build again. It probably will take a while. What happens is in the background, my Rust analyzer is refreshing, so it recompiles everything, and then when I run cargo build, I will actually finish the build in the terminal as well. So let's pause a bit until this finishes. Welcome back. This was slightly faster, like 50 seconds, but still quite a bit. I expect future compilations to be much faster. These were the big ones. Like when I do ESP IDF, it will compile quite a bit. In this case, I have everything needed for I2C, so let's read documentation. Hopefully it will open in this window. Amazingly enough, documentation compilation also takes a while, which you'd imagine it's faster, but okay. I have documentation. Perfect. So let's see what I want. I want I2C, and I don't want it from the embedded HAL. I think this is the generic one, so I want it from Espressif, so ESP IDF I2C, and I will start using this module. I have autocomplete, which is also nice, and I use I2C from here. And now I will look on, apparently a configuration exists, and master configuration, because the display is the I2C slave, and this is my master configuration. And when I look at it, I see that for the master config, I can call new, and I will get self, and then I can set some things. For example, I will set the pods, so I will do that. So I have config here. Actually, probably I don't need config, it's written enough. So let CFG equals I2C, a master configuration, and new. And what do I want to do on this new? I want to set baud rate, and baud rate is in hertz. Okay, what is hertz? I have units from a value type. I would imagine that this is, I want things in kilohertz, so I'll search for kilohertz and see how value type is implemented. Well, this didn't work in here. So if I use this straight from value, I think it is implemented for any value type. So let's import it. And I want my baud rate to be 400 kilohertz. Now this is kilohertz, it's not hertz, so I will want to convert it into hertz, and I think the conversion is automatically handled if I do into. See, I saved and I don't have any Rust Analyzer complaints, so this seems to be working okay. Now I will go back and see what else do I need. I want to create an I2C, and I would like to see how I can create a master I2C. When I look at it, a master I2C, I have a new function, and in this case I need to provide it the master pins and the configuration, and an I2C. So let I2C equals, I have a master configuration and I need to create a new one. At this point I have to provide arguments, so I have to provide some I2C. I don't know what that is yet, but I will figure it out. I have to provide the pins. I still don't know what they are, but I do know what the configuration is, and I think I can just copy and paste. I don't need to have a separate individual information about it. I have the config. I do not have the I2C, and I do not have the master pin. So first of all, let's see what I2C is. I'll use I2C. And I expect it to be somewhere in some peripherals. So if I look at this, I2C0 is in the peripherals. And when I look at peripherals themselves, these are the HAL peripherals. It has the option to say take, and it will return an optional self. The reason for this is the first take will succeed and the second one will fail. The intent is that you only get the peripherals once. You don't have conflicting configuration when you set up your MCU. I know I am only getting it once. So I say peripherals, take. I think it doesn't know what peripherals is. It takes it from the prelude. I don't think I want it from the prelude. I want it from peripherals. And I know I'm not misusing it, so I'll do unwrap. I don't need to do error handling. So let peripherals is this, and peripherals dot and I2C0. This is I2C, and then I will need to find out what the pins are. See, so master pins. Master pins is a structure that I have to provide a data line and a clock line, and it tells me the data line is an input-output pin and the clock line is an output pin. So I will make data and clock, so I say clock and data, and assuming they are of the right type, which they are not yet, I will say master pins SDA is SDA and clock is clock. Obviously this will not compile because the types are totally wrong, but I will fix the types. Let's see what the types could be. So it's an input-output pin, so it will be a GPIO. So in this case I will need a GPIO pin, and when I search for GPIO pin, I should see pin 0 and pin 4 and pin something like that. So let's search for pin 4. Usually GPIO 4. So when I look at GPIO, I will see various GPIOs, 4, 5, and so on. And when I look at them, it's implemented under pins. If I look for the structured pins, they should be somewhere in peripherals. So when I go into these peripherals that I got here, they should have a structured pins. I will use 4 and 5 for simplicity. This is not yet good. It will give me some error. So let's see peripherals. So I didn't use the correct namespacing. Let's see what else. It should complain here about GPIO pins. GPIO 4, and notice that it says GPIO 4 of unknown and unknown. This means it doesn't know the use. So you have to set the pin into a specific mode. So for example, if you use PWM, it will be PWM mode. If it will be input output, it will be input output, and so on. This is exactly what the documentation tells us. So the documentation for I2C, it says SDA has to be input at output. So this is the data, and I will say into input output, and GPIO 4 should be output. Let's see how far we created it. So this function takes 3 arguments, but 4 were provided because I did extra pins here. The other thing that you can see that it tells me that this is a result. So every operation can fail, which is probably correct. Right now I will not handle errors. I'll just say unwrap. And the device will crash if I actually made an error. ESP32-C3. Oh, because this is SCL is the name that the master structure, the master pin structure takes. No diagnostics, perfect. So now I2C, you can see that this is also a result. So actually I want to unwrap. Right now I will assume that nothing fails. So let's say cargo run. Actually I have to do the ESP flash. And my intent here is to see if it crashes. If it crashes, it will be quite obvious because it will be a boot loop. If it doesn't crash, I expect a println that says hello world. So it says hello world, and interestingly enough in the documentation, I also see in the logs that GPIO 4 and 5 are set in some specific name and mode. So this is pull up right now. This is fair. So I have an I2C. Now I want to do a display driver. So I will cargo search 1306, and I will add this to my crate because I want my display driver to work. And I will restart the documentation so that new crates are discovered. So this is the 1306, the display driver, go top level, and I will copy and paste the example. So I see I need embedded graphics. I don't know what their version is, so I will try to use cargo 3. I will see what SSD actually uses. It uses display interface, it uses embedded graphics core, and so on. This is not ideal. I previously copied some of the examples, and I will do the same in this case. I think just embedded graphics should be sufficient. So I will put embedded graphics 0.7. I wonder if I will see here. It doesn't show. That is fair. I got it from the TOML that was describing how to use SSD 1306. At this point, everything should kind of work. So I'll go into main RS, and I will do these uses, and then I will copy the interface. I already created the I2C. And let's see if cargo build works. Maybe very well that my Rust analyzer did not reset. I don't think I use buffer graphics mode, so I can delete this, and I'll restart Rust analyzer. Reload project, so I don't have these errors on the console. It is restarted, and now the other thing is, remember, I put a clock on pin 4 and data on pin 5. Let me connect my display. This is one of the messiest boards that I ever had. If you take a look at it, you will see that, let me do a full screen camera, the silk screen is at the bottom, so that's why I don't actually use one of those breadboards, because this is really nasty to work with. So let's see, I need to connect ground 3.3 volt, and after moving the display a bit to make it more visible, let's start and compile and execute. I expect it to say hello world and hello Rust. This is excellent, and what I would also want to do is at some point over here I'll want to test Wi-Fi. So let's pretend the IP is some sort of a string. And I would like to display the IP below. So I will pretend here that this is an IP, and I will use format to display it. And I don't need to do anything else for the SSD. Let's see if this works. I don't have yet IP implemented, but hopefully I will do it next. So once this finishes, I expect the display to say IP is just a test. Well, obviously the IP is not that. Let's implement Wi-Fi test. Now I'll call it get an IP, and it doesn't take any arguments, but it returns a result of string. And instead here I will get an IP and unwrap or say error. For result I will use something called anyhow, which seemed to be really useful to map errors. So I will go in here and I will say use and for now I will always return an error. It says not implemented fully. So my expectation would be right now that I will get an IP and I will say use anyhow and use anyhow result. Use everything from anyhow, so I don't need to namespace all these macros. It implemented the std result. How about this? Because I put a semicolon, okay? Perfect. So now if I run, I expect this to say IP not implemented fully. Actually, it will say error, but that's fine. I can match it. So let's say match get an IP. And this could be a string. Okay, IP. Let's say I return just a string IP, or if it's an error of E, then I will return an error. How about this? Expected tuple or tuple variant, font function okay, and the format is not a macro. I'm guessing I should use the hint, so it says importing one of these. Use core result okay. Sure. okay, and errors are from the result. Perfect. Let's run it and see the IP. Right now the IP should say error not implemented fully. Error not implemented fully. Excellent. Now I'll use the cargo documentation and I will figure out what else, or at least how I can implement Wi-Fi functionality. And if I search for Wi-Fi, I will find that embedded services has a Wi-Fi and ASP IDF has Wi-Fi. The difference between these two is that embedded services Wi-Fi is a generic interface. So this means when I use one board or another, I will have the same interfaces implemented. So this means I can scan, I can set a configuration, I can get the current status. And ESP32 has its own Wi-Fi that has creation arguments, and it has wait options, so I don't call wait status in a busy loop and so on. So let's use ESP Wi-Fi. So I will say let Wi-Fi is ESP Wi-Fi new, and I will see that I need to give it some reference counted items, and for ESP net interface stack and so on. When I look at each of these have a method new that just returns a result, and it takes no arguments. This applies for the system loop stack and the non-volatile storage as well. Like, it's just a result. So in this case, what I will do in here, I will say arc new and net interface stack new, and this may fail, and I want to return an error if it fails. The same for the entire Wi-Fi. And I need to pass three things: sysloop tag, and I need to non-volatile default NVS. It doesn't know what arc is. I think it's std sync arc should be the replacement. It added it somewhere at the top here. Let's see if this makes Rust analyzer happy. Sure, but it doesn't use Wi-Fi. So let me use Wi-Fi. So first of all, for me to connect, I will need to use the Wi-Fi that is generic, this implementation ESP Wi-Fi, and for this I have to be able to set the configuration, and it requires a mutable Wi-Fi. Let's make this mutable, and let's set configuration on it. And now I'll have to go through all of these items. So first of all, I will need to go through configuration. So the configuration will be configuration. Amazingly enough, I need, like, if you look at the bottom here, this is Ethernet. So if I select Ethernet, that will be no good. So I keep scrolling until I say it's a Wi-Fi configuration. And what kind of configuration? Well, a client configuration. And for a client configuration, I check again, it's for IPv4. I don't care for IPv4, I need generic Wi-Fi configuration. And this one is a structure. It has SSID, it has password, and various other things. I know SSID password, so I will use those. I made some temporary Wi-Fi for me to test. Let's put something, and the rest I only want default values, so I will use default. Let's see if this makes the analyzer happy. Almost, except I put too many dots here. It should be only 2. And I think it requires a reference. These auto insert of types make it hard for me to type. Let's see, it's unused result. Fine. Let's return a result in case of an error. And now wait for connection and return IP. I assume at this point, once I set configuration, it will start connecting, but I have to wait for it to connect. And the way to wait is if I look at the ESP Wi-Fi configuration or structure, it has all sorts of methods. One of them is wait for status, wait for a specific status, and then wait for status with a timeout. I think I want a timeout, so let's do that. Wait for status with timeout. It will ask me how long do I want to wait. I'll say duration from seconds, let's say 20 seconds. And then it will ask me for a matcher, which in this case, it will be lambda status. And I want to see what can I do with the status. If I click on it, it has two fields, like 0 is a client status and an access point status. But the interesting things are there is an implementation task. Is this transitional? Like this is like the status like connecting. It's not the final one. So I want this to only stop if status is not transitional. This should be compact enough. And the error type is probably not a supported error. This would be my guess. So let's error map. And convert it into a anyhow error. And it returns a status that was not valid. Okay, so this means when this one finishes, the status did not manage to finish in time, so it will say error connecting. At this point, I should have a valid status. So I'll say let status equals Wi-Fi get status. The trouble with the status is that it's quite complex. Like it's a client status, the client status is a started, and so on. So I will have to match it. And the way I will do this, I will say let IP and let's say match status. And it would be something, let's say, want to match status.0. And let's say if it's a client status, if it started of something, I will return OK for now. Otherwise, I want to return an error of invalid status. And once I have an IP, I will say, OK, I have the IP. Let's see if I have make Rust Analyzer happy. It doesn't know what client status is. It is in embedded SVC Wi-Fi. So let's import everything from here. Oh, this is ESP1. Let's import everything from here, so I don't need to import one by one. This is not ideal. Now, Rust Analyzer, I can close the browser at this point. Rust Analyzer tells me this is a client connection status, so let's do that. So it's a client connection status of connected, and let's say it's a client IP status. And what is the status? Status client IP status done, settings. And out of the settings, I think I can get the IP, and I will just print it out as debug as well. It's very lazy, but it works. It's an IPv4 address. That's odd. How do I get IPv6s? But fine. So this is the match. It will return a string, and the string will be settings IP from this very, very long item. And otherwise, it will return an error. So let's compile this and run. Not cargo doc open. Compile and run. my expectation is that once this flashes, it will connect to the Wi-Fi and it will display a little bit of an IP. And you can see the size of the binary increased significantly. Right now there are 417 chunks. You can see it goes through hello world, and if you look at the screen in the lower right, there is an IP address. So if I zoom in, I got an IP address, and looks about right. So at this point, I have a project that is capable to connect to Wi-Fi and is able to display something on the screen. And with this, you can build clients, or you can build HTTP servers, and so on. I hope this was interesting or useful, or both. Have a great day. Bye.